Electromeric effect is an important organic reaction which helps us in deciding whether the pi electron cloud is moving towards atom A or B. We can check out with an example here. For example, we have two atoms here, A and B, and it has a multiple bond. This is a pi bond. Pi bond has two electrons, and these are properly shared between these two atoms A and B. When there is an agent involved, for example, I have keeping an agent E here, and the pi electron cloud is moving towards B, for example. So in that case, what will happen here is, because B is getting the pi electron cloud, B will get negative charge and atom A will be getting positive charge. So this displacement of pi electrons between two atoms, here we are taking an example of A and B, towards B atom, which leads to formation of a negative charge on B and positive charge on A in the presence of an agent. Here we are calling it as reagent. For example, is called as electromeric effect. Electromeric effect is reversible reaction. It is temporary reaction or temporary effect. And we can represent this particular compound A with positive charge as that A has lost an electron share, this electron share which is pi electron share, and B has gained pi electron share, that is why B is represented as negative charge. In modern chemistry, we define electromeric effect as complete transfer. This is the transfer of pi electrons to one of the atom in the presence of attacking reagent. So this reagent is called as attacking reagent. We can write, instead of A and B, two carbons here, which is bonded to two hydrogens. This is ethylene. This ethylene, in the presence of a reagent, I can take here an electrophile, so which is represented as E with a positive sign, and if this is displaced here, this is pi electrons. Now we will write it as single bond with two carbons, so, and two hydrogens are as it is. And the carbon here, because it is moving here, sorry, pi electrons is moving here, it will give negative charge, and carbon is having a positive charge. The curved arrow, which is actually represented here, shows the displacement of pi electron. Displacement is nothing but movement. So the curved arrow represent displacement. Displacement is nothing but movement of pi electrons. There are few important characteristics of electromeric effect. Electromeric effect, I said, it is a temporary effect. It takes place in compound having multiple bond. Multiple bond can be double bond or triple bond. Electromeric effect is denoted by E. It is of two types, plus E effect and minus E effect. The transfer of electron is represented by curved arrow, I have said. If the attacking reagent is withdrawn without the reaction being allowed to take place, so it means that, for example, we have represented A double bond B in the presence of a reagent E. So this is displaced here, we are getting A positive, B negative. When I remove this E, that is a reagent or attacking reagent, this reaction can be reversed. That means A positive, B minus and once again become A double bond B when you remove this E. So it is represented in this way. If the attacking reagent is withdrawn, that is removed, the reaction being allowed to take place, that is electron displacement, reverts back or come back to the normal position. This is the normal position. There are two types of electromeric effect. Electromeric effect, that is plus E and minus E. In plus E, the example we can quote here is this. It has two bonds here, plus H plus. The pi electron cloud moves towards this carbon. If the attacking reagent here, that is H plus or attacking species, goes and binds to the carbon where the displacement is happening, here the displacement is happening, that effect is called as plus E effect. That means we are going to have this carbon as it is, double bond will change to single bond, once again carbon, here one bond was there, here it will be H. And already one bond was there with carbon. So in that case, carbon will have positive charge as we have represented in A, comma B, where it has positive charge. So this positive charge attacking reagent goes and attack to that carbon which is getting the pi electrons. So here it is getting displaced. Your positive species is coming up and attacking here. So this particular effect is called as plus E effect. In the case of minus E effect, the pi electrons of the multiple bond are transferred to the atom to which attacking reagent does not get attached or do not get attached. So for example, you have carbon double bond O with two bonds to carbon. You have got Cn minus is the nucleophile, not electrophile. So because you know carbonyl compound, this pi electron moves towards oxygen and it will get negative charge, and the negative charge species, that is Cn minus cyanide ion, will go towards carbon because it will have positive charge. So in that case we are going to get carbon with two bonds already, oxygen will change to O minus and we have Cn attached to carbon, and this type of effect is called as minus E effect. So there are two types of electromeric effect, plus E and minus E effect. Electromeric effect is of two types. It is a temporary effect, as we have discussed. It is possible in multiple bonded atoms where we have double bond and triple bond. We have one more important thing to remember here is it is a reversible and the displacement of pi electron is showed by a curved arrow. This is what you need to remember in this particular topic of electromeric effect. An important effect which we are going to discuss next in our next upcoming video, which we will discuss today itself, that is inductive effect, which is also very important and it is little bit more lengthy than this. First, I advise you all to go through this reaction which this particular topic which we have covered just now, and the remaining we will discuss after few hours. Thank you.